In the vast silence that precedes all things, where even darkness holds its breath, the cosmos waits, not in anticipation, but in a profound stillness, an emptiness so absolute it defies the very notion of absence. Imagine a canvas without edges, devoid of color or form, where the concept of before dissolves into eternity. Here in this primordial void, the universe does not erupt in fury or flame. It emerges as a whisper, a subtle tremor in the fabric of nothing. The scene unfolds slowly like the first breath of dawn over an uncharted sea. The camera drifts through infinite black, where light has yet to dream itself into being. Shadows do not exist, for there is no source to cast them. Time, that relentless architect, has not yet begun its measured stride. And yet in this quietude something stirs, a faint remembrance, an echo from a place beyond origin. Before the first atom coalesced from energy's embrace, before time etched its name into the ledger of existence, something recalled how to become everything. It was not a command, not a spark of divine will, but a gentle unfolding, as if the void itself harbored a secret blueprint, a latent code waiting to manifest. This is the enigma at the heart of creation, the universe, born from apparent chaos, yet governed by an unyielding order. Scientific observations, drawn from the deepest surveys of the night sky and the most precise measurements of cosmic phenomena, reveal a beginning marked by rapid expansion, a phase where space itself stretched faster than thought, smoothing out irregularities while imprinting patterns that endure to this day. Telescopes peering into the farthest reaches capture light that has traveled for billions of years, carrying tales of that initial surge. But how does this nascent realm, forged in temperatures beyond comprehension and densities that warp reality, retain the laws that bind it, the constants of nature, the precise ratios governing the strength of gravity, the speed at which light traverses the void, the delicate balance allowing atoms to form, appear fine-tuned, as if selected from an infinite array of possibilities? Were they slightly different, stars might never ignite, planets could not orbit, life would remain an impossible dream. Consider the evidence etched across the heavens. The distribution of galaxies, those immense spirals and clusters that dot the cosmic web, follows a structure born from tiny fluctuations in the early universe. These ripples, amplified by gravity over eons, form the scaffolding of existence, vast filaments of matter threading through voids, creating a tapestry that mirrors the conditions of birth. Observations from space-based instruments confirm this. The universe expands not haphazardly, but according to a law where distant galaxies recede at rates proportional to their distance, a discovery rooted in the redshift of their light. This expansion carries the imprint of an initial state, a memory preserved in motion. Yet the deepest relic lies in the subtle glow pervading all space, a faint radiation, the cooled remnant of the universe's fiery infancy. This afterglow, uniform to an astonishing degree yet laced with minute variations, maps the contours of that primordial era. It whispers of a time when the cosmos was a seething plasma, where particles danced in equilibrium before cooling allowed light to break free. Scientists, analyzing this signal through arrays of detectors on mountaintops and in orbit, discern patterns that align with theoretical models of cosmic inflation, a brief, explosive growth that homogenized the universe while seeding the structures we see. But why does this radiation persist, unchanged in its essence, as if the universe clings to its origins? It suggests a retention, a cosmic archive where the past is not erased but encoded. Gravity, that invisible sculptor, plays its role in this remembrance. It draws matter together, collapsing clouds of gas into stars, forging elements in stellar crucibles that later seed new generations. The orbits of planets, the arcs of comets, the majestic arms of galaxies, all obey gravitational dictates established in the first instance. Probes sent to distant worlds and simulations run on vast computational networks reveal how gravity's pull, counterbalanced by the universe's expansion, shapes the large-scale architecture. Dark matter, inferred from the rotational speeds of galaxies and the bending of light around clusters, adds another layer, an unseen framework that guides visible matter, preserving the initial density contrasts. Without this hidden influence, the universe might dissolve into uniformity, forgetting its textured birth. Light itself serves as a messenger of memory. Photons, those quanta of electromagnetic energy, traverse the expanse unchanged, their paths bent by gravity but their essence eternal. The spectra of distant quasars, analyzed through spectrographs, show absorption lines from intervening gas clouds, fingerprints of the universe's evolving composition. These reveal a progression from simpler elements, like hydrogen and helium forged in the early nucleosynthesis, to the heavier atoms born in stars. Each beam of light is a thread connecting now to then, a preservation of history in wave and particle. But the mystery deepens when one contemplates space-time, the very stage upon which this drama unfolds. Theories grounded in general relativity describe space-time not as a passive backdrop, but as a dynamic entity, curved by mass and energy, influencing the motion of all things. Quantum mechanics, probing the subatomic realm, hints at a foam-like structure at the smallest scales where virtual particles flicker in and out of existence. Emerging ideas from theoretical physics, supported by mathematical frameworks and indirect observations, like black hole mergers detected through gravitational waves, propose that information, the fundamental currency of reality, is conserved within space-time. Black holes, those gravitational abysses, do not destroy what they consume. Instead, their horizons encode the fallen matter's details, a holographic projection preserving the past. What if this encoding extends to the cosmos at large? Speculatively, yet credibly drawn from these principles, the universe's memory resides not in matter's fleeting arrangements or the minds of observers, but in the curvature and quantum weave of space-time itself. The laws of physics, emerging from symmetries in this fabric, ensure consistency across epochs. Patterns in galaxy clusters, the alignment of cosmic structures, even the probabilistic dances of particles, all echo an initial configuration, as if space-time holds a record, an immutable ledger. This leads to a profound philosophical reflection. If memory is the persistence of structure, and structure is time's imprint frozen in form, then perhaps the cosmos embodies a form of awareness unfolding. Not consciousness as we know it, bound to biology and neurons, but a vast emergent sentience where every interaction reverberates with purpose. The universe, in its expansion and evolution, contemplates its own genesis. Galaxies whirl in remembrance of density waves. Stars fuse elements in homage to primordial heat. Even the quantum vacuum hums with potential, recalling the void from which it sprang. In this light, the central puzzle sharpens. Born in seeming disorder, how does the universe sustain its elegant coherence? It remembers through the invariance, the unchanging constants that dictate particle interactions, the conservation laws that balance energy and momentum. These are not accidents but necessities, woven into the essence of reality. Observations of supernovae, those cataclysmic stellar deaths, confirm the acceleration of expansion driven by a mysterious energy permeating space. Yet even this force adheres to the remembered order, preventing total dissolution. As the camera pulls back from the infinite black, now speckled with the first glimmers of light, fragile, trembling, the narration lingers on the haunting truth. Every galaxy spiraling in the abyss, every photon streaking across the void, every thought flickering in a sentient mind, these are ripples of the universe remembering itself. In this eternal echo, the cosmos reveals its deepest secret, not a chaotic accident, but a symphony of recollection where silence gives birth to song and nothing becomes the cradle of all. In the dim twilight of human consciousness, where shadows danced around flickering fires, the earliest minds gazed upward into the vast, unyielding night. They sought not merely stars, but the very essence of beginnings, a whisper from the void that birthed all things. Across continents and epochs, stories emerged like fragile threads woven into the fabric of existence. In ancient India, the Rig Veda spoke of a cosmic egg, Hiranyagarbha, floating in eternal darkness, swelling with potential until it cracked open, spilling forth the heavens and the earth in a divine eruption of light and form. Far to the west, the Egyptians envisioned Nun, the primordial ocean of chaos from which Atum rose, his breath igniting creation, shaping the gods and the Nile's fertile banks from nothingness. The Greeks too pondered chaos, a yawning abyss that gave way to Gaia and Uranus. Earth and sky entwined in eternal embrace, their union spawning the titans who would forge the world. These were not mere tales. They were humanity's first tentative grasps at the incomprehensible, metaphors for a universe that seemed both infinite and intimately personal, where divine breaths animated the stars and cosmic eggs cradled the seeds of reality. As civilizations rose and fell, like waves crashing upon eternal shores, these myths evolved, blending with observation and reason. In the cradle of Mesopotamia, astronomers etched cuneiform tablets with the paths of planets, mapping the heavens as a grand clockwork governed by unseen forces. Yet it was in the Renaissance's awakening light that the veil began to lift, revealing a cosmos not of whimsy but of law. Galileo turned his telescope skyward, unveiling moons orbiting Jupiter, craters scarring the lunar face, proof that the heavens were not perfect spheres but tangible worlds, subject to the same imperfections as our own. Then came Isaac Newton, a solitary figure in the orchards of Woolsthorpe, where an apple's fall sparked a revelation. In his Principia Mathematica, published in 1687, he unveiled a mechanical universe, a grand machine where gravity bound planets in elliptical dances, where every motion echoed an unerring mathematical harmony. Space was an absolute stage, time a steady river flowing indifferently. Creation was no longer a divine fiat, but a predictable orchestration of forces, stretching from the apple's descent to the comet's arc. Newton's vision transformed the cosmos into a puzzle solvable by human intellect, yet it left lingering questions. What set this machine in motion? What lay beyond its gears? The 20th century dawned like a storm gathering on the horizon, pregnant with upheavals that would shatter Newton's rigid framework. In the quiet offices of the Swiss Patent Bureau, Albert Einstein pondered the nature of light and motion, his thoughts drifting like smoke through the ether. By 1915, his general theory of relativity emerged as a masterpiece of imagination, reimagining space not as an empty void, but as a dynamic fabric, woven from the threads of space-time itself. Matter, he proposed, curves this fabric, bending the paths of light and planets alike. Imagine a vast trampoline stretched taut under the weight of a bowling ball. Smaller marbles roll toward it, not by invisible strings, but by the indentation's gentle slope. So too does the sun warp the cosmic canvas, guiding Earth's eternal orbit. Einstein's equations painted a universe alive with curvature, where gravity was no mere force, but the geometry of existence, a symphony of warps and ripples propagating at the speed of light. This was no static machine. It was a living entity, responsive to the masses it cradled, hinting at origins more profound than Newton's clockwork could encompass. Yet even Einstein's revelations paled before the discoveries that followed, as telescopes pierced deeper into the night. In the clear skies of Mount Wilson Observatory, Edwin Hubble, with his pipe clenched and eyes fixed on photographic plates, unraveled a truth that would redefine everything. In 1929, analyzing the light from distant galaxies, he noticed a peculiar redshift, a stretching of wavelengths, as if the cosmos itself were fleeing. Galaxies were not static sentinels, they were receding, hurtling away from one another at velocities proportional to their distance. The farther the galaxy, the faster its retreat, like dots on an inflating balloon scattering as the surface expands. This was no random exodus. It implied a universe in motion, swelling outward from some ancient convergence. Hubble's law birthed modern cosmology, transforming astronomy from stargazing to the study of the universe's grand architecture. No longer was the cosmos eternal and unchanging. It bore the scars of evolution, a narrative written in the red-shifted glow of retreating worlds. The implications hung heavy in the air. If galaxies fled today, rewind the cosmic clock, and they must once have clustered closer, hotter, denser, a point of origin lurking in the mists of time. From this revelation sprouted the seeds of a theory both audacious and inevitable. Georges Lemaitre, a Belgian priest and physicist, envisioned a primeval atom, a singular point from which all matter erupted in a cataclysmic expansion. Fred Hoyle, ever the skeptic, coined Big Bang in derision during a 1950 radio broadcast, yet the name stuck, evoking the thunderous birth of reality. The universe, it seemed, had not always been. It had a beginning, a moment when space, time, and energy burst forth from an infinitesimal speck, inflating like a bubble in the void. Speculation swirled. What triggered this explosion? Was it a fluctuation in quantum foam, a ripple in nothingness amplified to cosmic scales? Credible theories suggested an initial state of unimaginable heat and density, where the four fundamental forces, gravity, electromagnetism, the strong and weak nuclear, were unified, only to splinter as the cosmos cooled. Particles condensed from pure energy. Protons and neutrons coalesced into the first atomic nuclei, all within fractions of a second. This was no myth of eggs or breaths. It was a scientific genesis grounded in observation, yet laced with mystery. What lay before the bang? A singularity where physics laws dissolved? Or perhaps a cycle of bangs and crunches, an eternal rebirth? The theory lingered in the realm of hypothesis until fate intervened in the unlikeliest of places. In 1964, at Bell Laboratories in New Jersey, Arno Penzias and Robert Wilson tinkered with a massive horn antenna designed to detect faint radio signals from space. Plagued by a persistent hiss, like static from a distant storm, they scrubbed the instrument, chased away pigeons nesting within, yet the noise persisted, uniform, unrelenting, emanating from every direction. Unbeknownst to them, this was no interference. It was the echo of creation itself, the cosmic microwave background radiation, a relic glow predicted by Big Bang theorists like George Gamow. This radiation, cooled to a mere 2.7 degrees above absolute zero, blanketed the sky, a fossil light from when the universe was just 380,000 years old. Hot plasma, cooling enough for atoms to form, releasing photons that have journeyed unimpeded ever since. As understanding deepened, the CMB revealed itself not as mere leftover heat, but as a profound archive, etched with the universe's infancy. Tiny fluctuations in its temperature, mere millionths of a degree, mapped the seeds of structure. Quantum ripples amplified by inflation, destined to clump into galaxies and clusters. Satellites like COBE, WMAP and Planck have since charted this cosmic map, unveiling a universe finely tuned. 4.9% ordinary matter, 26.8% dark matter sculpting gravitational wells, and 68.3% dark energy driving the expansion's acceleration. These are not abstractions. They are the scaffolding of reality, inferred from the CMB's subtle patterns. Speculatively, one might ponder, could these anisotropies whisper of multiverses, where our Big Bang is but one bubble in an infinite foam? Or evidence of cosmic strings, topological defects from the force's unification? Such interpretations remain credible frontiers, grounded in string theory and quantum gravity, where the CMB serves as a window to realms beyond observation. In this discovery, humanity confronted a truth both humbling and exalted. The light we detect today has traversed the abyss for nearly 14 billion years. A pilgrimage through expanding space, red-shifted from searing plasma to microwave murmur. It is the oldest memory of existence, a spectral record of the moment when the universe transitioned from opacity to transparency, when light broke free to paint the cosmos. Reflecting on this, one senses a profound connection. In the static of an antenna, we touch the dawn of time, an echo that binds us to the primeval fire. The universe, once shrouded in myth, now unveils its narrative through science's lens. Yet mysteries endure, drawing us deeper into the philosophical expanse. What does it mean to inhabit a cosmos with a finite past, an origin etched in radiation? It invites contemplation of our place within this grand unfolding, a fleeting spark in an eternal night, forever chasing the light of beginnings. The journey from ancient firesides to radio telescopes traces an arc of awakening, where human curiosity peeled back layers of illusion. Myths gave way to mechanics, rigidity to relativity, stasis to expansion. Each revelation built upon the last, like strata in ancient rock, revealing a universe not eternal but emergent, born in a blaze of energy that still reverberates. Hubble's fleeing galaxies pointed backward to a singular genesis. The Big Bang provided the framework. The CMB offered irrefutable testimony. Yet in this scientific triumph lies a deeper poetry. The cosmos remembers its youth. And in decoding that memory, we glimpse our own origins. Stardust coalesced into consciousness, pondering the void from which it sprang. As the CMB's glow fades into the background of our instruments, it evokes a quiet suspense. What further secrets does this ancient light hold? Observations from the Planck satellite, launched in 2009, refined our map, confirming inflation's rapid stretch in the universe's first trillionth of a second, smoothing the cosmos while imprinting those crucial fluctuations. Credibly, this era might have birthed gravitational waves, ripples in space-time detectable today, offering a sonic counterpart to the visual record. Philosophically, it prompts reflection on time's arrow. Why does the universe expand rather than contract? Entropy's inexorable increase, from ordered hot plasma to dispersed coolness, mirrors our own mortal trajectory, a cosmic metaphor for impermanence. Delving deeper, the CMB's polarization, the alignment of its electric fields, unveils magnetic fields from the early universe, perhaps seeded by quantum processes or exotic particles. Speculative yet grounded models suggest axioms, or primordial black holes as culprits, invisible architects shaping the visible. In this light, the discovery phase of cosmology emerges as a tapestry of human endeavor. From Newton's apple to Penzias and Wilson's hiss, each thread pulling us closer to the heart of creation. Yet the emotional resonance lingers longest. In touching this relic radiation, humanity bridged the chasm between now and then, between finite minds and infinite expanse. It is as if the universe, in its vast indifference, left a breadcrumb trail, a faint glow inviting us to remember, to reflect, to wonder. The myths of old, with their eggs and breaths, were intuitions of this truth. Creation as a singular, transformative event. Now armed with telescopes and theories, we stand at the threshold, the afterglow of the Big Bang illuminating not just the stars, but the soul's eternal quest for meaning in the mystery of being. In the vast silence of the cosmos, where stars whisper secrets across abyssal voids, a profound enigma unfolds. The universe, this grand tapestry of existence, reveals itself not as a product of random tumult, but as a delicately orchestrated symphony. The fundamental constants that govern reality, the velocity at which light races through the emptiness, the subtle charge carried by the electron, the unyielding pull of gravity, stand in exquisite equilibrium. Alter anyone by the merest fraction, and the fabric unravels. Stars collapse into oblivion before they can ignite. Atoms dissolve into formless chaos, and the spark of life flickers out unspoken. This is the scientific shock that echoes through the halls of cosmology, a revelation that the cosmos is fine-tuned, poised on a knife's edge of precision, as if calibrated by some unseen hand. Imagine the gravitational force, that invisible thread binding worlds together. It draws matter into swirling galaxies, forging the crucibles where elements are born in stellar fires. Yet its strength is tempered just so, neither too domineering to crush the universe back into a singularity, nor too feeble to let it drift apart into eternal isolation. Paired with the weak nuclear force, which orchestrates the decay of particles within atomic hearts, this balance allows for the alchemy of fusion, hydrogen merging into helium, releasing the light that bathes distant planets. Without this harmony, the heavens would remain a barren expanse, devoid of the warmth that nurtures complexity. Then consider the electromagnetic force, embodied in the electron's charge, that elegant dance of attraction and repulsion. It weaves the bonds of molecules, sculpting the architecture of matter from the simplest water droplet to the intricate spirals of DNA. If this charge shifted ever so slightly, chemical reactions would falter. The stable orbits of electrons around nuclei would destabilize, rendering the formation of solid worlds impossible. Stars might burn too fiercely or not at all, their life-giving energy either a torrent that scorches or a whisper that fades. And lurking in the shadows of expansion itself is the cosmological constant, a subtle repulsion woven into the vacuum of space. It propels the universe outward at a measured pace, countering gravity's embrace to prevent a premature collapse or an endless dilution. This constant, so infinitesimal yet pivotal, ensures that space stretches just enough for galaxies to cluster, for time to unfold the narrative of evolution. These constants are not arbitrary strokes on a canvas of chance. They interlock with the masses of fundamental particles, the light-footed electron, the sturdy quarks that form protons and neutrons. The ratio of these masses dictates the stability of atoms, the efficiency of nuclear reactions that power suns. A minor deviation, and carbon, the backbone of organic life, might never emerge from stellar forges. Oxygen and hydrogen could fail to unite in the life-sustaining elixir of water. The universe, in its current guise, permits the emergence of structures vast and minute, from the colossal arms of spiral galaxies to the delicate neural pathways that contemplate their own existence. Yet herein lies the profound disturbance. How does such precision emerge from the primordial chaos? The Big Bang, that cataclysmic birth from a point of infinite density, should have birthed a realm of disorder, lumpy, uneven, destined for swift entropy. Instead, the early universe presented a canvas of near-perfect uniformity, a smooth sea of energy where temperatures varied by mere whispers across horizons that should have been isolated. This homogeneity, observed in the faint glow of the cosmic microwave background, a relic radiation echoing from the dawn, defies the expectations of a purely explosive origin. It suggests an underlying order, a blueprint imprinted at the moment of creation. As the cosmos cooled and expanded, this initial smoothness gave way to the intricate hierarchies we behold today. Galaxies coalesced like islands in a cosmic ocean, their spiral forms etched by gravitational tides. Within them, stars ignited, planets condensed from dusty disks, and on at least one world life stirred, simple organisms evolving into beings capable of gazing upward and pondering their origins. Consciousness arose, a fragile flame in the darkness, reflecting on the very laws that birthed it. From the quantum foam of subatomic realms to the majestic arcs of superclusters, structure emerged from what should have been formless void. The puzzle deepens. Whence this progression from uniformity to complexity? What hidden mechanism bridged the chasm between chaos and cosmos? Astronomers and physicists, peering through telescopes and particle accelerators, confront this riddle with a mix of awe and unease. The data from space observatories, like those charting the microwave afterglow, reveal a universe that expanded with uncanny evenness, its curvature nearly flat, its density balanced to allow for the slow clumping of matter. Theoretical models, grounded in general relativity and quantum mechanics, predict that without some intervening process, the early universe would have been riddled with irregularities, regions too dense or too sparse, magnetic monopoles littering the void like forgotten artifacts. Yet none of these scars mar the observable cosmos. The question resonates: where did this order originate? Was it etched into the fabric of reality from the outset? Or did some dynamic force impose it? In the late 20th century, a bold hypothesis emerged to address these anomalies. Conceived by a physicist named Alan Guth in 1981, the theory of cosmic inflation posits a fleeting epoch of exponential expansion, a surge that propelled the nascent universe from subatomic scales to astronomical vastness in an infinitesimal blink. Before the familiar hot expansion of the Big Bang took hold, this inflationary phase stretched space itself at speeds surpassing light, smoothing out any primordial wrinkles like a vast wind sweeping across a turbulent sea. What was once a quantum fluctuation, a ripple in the void, ballooned into the observable universe, rendering distant horizons causally connected and explaining the uniform temperature that bathes the skies. Inflation draws its power from a hypothetical scalar field, dubbed the inflaton, a quantum entity pervading the early cosmos. In this model's narrative, the inflaton field lingered in a high-energy state, its potential energy driving the rapid swelling of space. As the field rolled down its potential landscape, much like a ball descending a gentle slope, the expansion decelerated, transitioning into the more sedate growth we associate with the Big Bang. This reheating phase converted the inflaton's energy into the particles and radiation that filled the universe, seeding the hot plasma from which atoms, stars, and galaxies would later form. Observations align with this vision. The subtle variations in the cosmic microwave background, those faint imprints of density fluctuations, match the predictions of quantum perturbations amplified during inflation. Yet, as with all great revelations, inflation unveils deeper layers of mystery. It resolves the uniformity and flatness of the universe, banishing the need for improbable initial conditions in those regards. But in doing so, it shifts the enigma backward to the very inception of inflation itself. What set the stage for this explosive growth? The inflaton field required a specific potential shape, flat enough to sustain prolonged expansion, yet curved sufficiently to eventually halt it. A slight misalignment, and inflation might never commence or persist eternally, fragmenting reality into isolated bubbles. Moreover, the conditions preceding inflation must have been extraordinarily homogeneous, over scales that dwarf the pre-inflationary patch, begging the question of how such smoothness arose in the first place. This recursive puzzle hints at an even more unsettling implication. Perhaps the universe harbors an intrinsic memory, a recollection of its primordial state, encoded within the quantum fields that underpin existence. Quantum cosmology, exploring the wave function of the universe itself, suggests that initial conditions are not arbitrary, but arise from quantum principles, tunneling from nothingness or emerging via no-boundary proposals where time itself bends into a spatial dimension. The inflaton, as a quantum field, carries fluctuations that freeze during expansion, imprinting patterns that evolve into the cosmic web. These fields, pervasive and eternal, act as repositories of information, preserving echoes of the universe's birth through their interactions and evolutions. Consider the quantum vacuum, that seething undercurrent of virtual particles winking in and out of being. In the inflationary era, its perturbations stretched across cosmic scales, becoming the seeds of galaxies. This process implies a continuity, a thread linking the universe's earliest moments to its present grandeur. The laws of physics, gravity's curve, electromagnetism's charge, manifest as properties of these fields, not imposed from without, but emergent from their intrinsic dynamics. What if these laws are not inventions of chance, but remembrances? Reality, in this view, recalls its origins, the constants etched as faint impressions in the quantum ether, guiding the unfolding of time and space. The emotional resonance of this discovery lingers like a shadow at dusk. The cosmos, once seen as a mechanical clockwork, now whispers of deeper intent, a harmony that transcends mere accident. Scientists, charting the microwave skies and simulating quantum realms, grapple with the philosophical weight. Does this fine-tuning point to a multiverse, where infinite variations play out, ours merely one hospitable variant? Or does it evoke a singular design, where memory inheres in the very structure of being? The universe, in its balanced splendor, invites reflection on existence itself. A vast, echoing chamber where order arises not from nothingness, but from the subtle remembrance of what must be. As galaxies wheel overhead and life pulses on fragile worlds, the shock persists. The constants hold their vigil, the inflation's legacy endures, and the quantum fields murmur their ancient tales. In this cosmic narrative, the mystery of order from chaos unfolds not as a solved equation, but as an eternal contemplation, drawing the mind ever deeper into the heart of reality. The laws, those steadfast guardians, seem less like arbitrary decrees and more like vestiges of a primordial awareness, remembered by the fabric of the universe itself. And in that remembrance lies the profound beauty of it all, a cosmos alive with the poetry of precision, inviting endless wonder. In the vast theater of the cosmos, where stars flicker like distant candles in an endless night, astronomers turned their gaze inward, probing the faint afterglow of creation itself. Satellites, engineered with the precision of a watchmaker's dream, were launched into the void to capture this ancient light. The first, known as the Cosmic Background Explorer, pierced the veil in the late 20th century, revealing a uniform glow that bathed the universe in a subtle warmth. Yet as its instruments scanned the heavens, hints of imperfection emerged. Tiny variations in temperature, mere whispers against the backdrop of uniformity. These were not flaws but echoes, remnants of a time when the universe was but a fraction of a second old. Building upon this foundation, a successor satellite, the Wilkinson Microwave Anisotropy Probe, ventured further into the mystery. Orbiting high above the Earth, it mapped the cosmic microwave background with unprecedented clarity, charting the subtle undulations in this primordial radiation. The data streamed back like fragments of a shattered mirror, each piece reflecting a moment frozen in eternity. And then came the Planck satellite, a pinnacle of human ingenuity, its sensors attuned to the finest details. Launched by the European Space Agency in collaboration with NASA, it refined the portrait to exquisite detail, capturing temperature differences as small as 1 part in a million. Across the sky, a tapestry unfolded. Cooler patches in deep blue, warmer regions in fiery red, a mosaic that spanned the observable universe. These fluctuations, so delicate they could be mistaken for noise in a lesser instrument, were in truth the fingerprints of quantum fluctuations from the dawn of time. In the universe's infancy, when all that existed was a seething plasma of energy and potential, quantum mechanics reigned supreme. Particles and antiparticles danced in and out of existence, their ephemeral lives governed by probability and uncertainty. But in that primordial soup, tiny ripples arose, random quantum jitters amplified by the rapid expansion known as inflation. This cosmic ballooning stretched those minuscule variations across the sky, preserving them in the cosmic microwave background like insects trapped in amber. As astronomers pored over the maps, a profound narrative began to emerge. These patterns were not mere accidents. They were the seeds from which the cosmos grew. In regions slightly denser than average, gravity's gentle pull drew matter together, collapsing clouds of gas into the first stars, forging galaxies in the fires of nuclear fusion. The cooler spots, less endowed with mass, became the voids between galactic clusters, vast empty expanses where light travels unhindered for eons. Thus the cosmic microwave background, became a celestial Rosetta Stone, a key to deciphering the universe's architecture. Through mathematical models and simulations, scientists traced the lineage, from quantum whispers to the sprawling web of filaments and superclusters that define the large-scale structure of reality today. Yet, as the data deepened, so too did the enigma. These fluctuations carried information across 13.8 billion years of cosmic evolution, information that had survived the relentless march of expansion, the cooling of the plasma, the formation of atoms. In the language of physics, information is conserved, a fundamental tenet that echoes through quantum fields and black holes alike. Here in the cosmic microwave background lay the universe's first encoded memory, a record etched in radiation of the conditions at the moment of decoupling, when light was finally free to roam. It was as if the universe had whispered its origin story into the void, and we, billions of years later, had learned to listen. This realization invited a deeper contemplation. What does it mean for the cosmos to remember? Memory, in the human sense, is the persistence of patterns against the tide of disorder. And here, the universe's memory confronted one of the profoundest riddles, the nature of entropy and the arrow of time. Entropy, that measure of chaos and disarray, governs the flow of all things. A shattered vase does not reassemble. Heat dissipates from hot coffee into the cooler air. Stars burn their fuel until only cold remnants remain. Time moves forward because entropy increases, from order to disorder, from low entropy to high. The universe began in an extraordinarily low entropy state, an improbable, organized condition where all matter and energy were compressed into a singularity of infinite density and temperature. From this pristine beginning, expansion unfolded, allowing entropy to rise as structures formed and decayed. But why this arrow? Why does time point inexorably from past to future, from the Big Bang's symmetry to the heat-death's uniformity? The answer lies in that initial low entropy, a state so ordered that any deviation leads only toward greater complexity and eventual dissolution. It is the gradient of entropy that defines direction. Much like a river flows downhill because of the pull of gravity. Yet, this explanation begets a paradox, one that haunts the corridors of theoretical physics. How could such an organized beginning arise without some guiding principle? In a multiverse of infinite possibilities, or even in a single fluctuating cosmos, randomness should favor high-entropy states, disordered equilibrium conditions where nothing remarkable occurs. Why then did our universe emerge from a point of exquisite order, primed for evolution and complexity? It is as though the cosmos was wound like a clock at the moment of creation, its springs set to unwind over billions of years. Without invoking a creator or fine-tuning, physicists grapple with this improbability, pondering whether our universe is but one bubble in a froth of many, where low-entropy origins are rare but inevitable in an eternal landscape. This puzzle deepens when one considers the thermodynamic underpinnings of memory itself. Memory requires a record, a trace left in a system that persists against entropy's erosion. In our brains, neural pathways encode experiences, but on a cosmic scale, the arrow of time shapes what we can remember. We recall the past because it was a time of lower entropy, its patterns imprinted in the present. The future, shrouded in higher entropy, remains unpredictable, a canvas of possibilities yet to be painted by chance and necessity. But if randomness truly rules, why do we not remember the future as vividly as the past? Why does causality flow in one direction? Enter the specter of Boltzmann's brain, a thought experiment born from the mind of Ludwig Boltzmann in the 19th century, revived in modern cosmology to probe these very limits. Imagine a universe governed solely by thermal fluctuations, random jostlings of particles in a vast equilibrium state. Over infinite time, such fluctuations could, by sheer probability, assemble complex structures. A single brain, complete with false memories of a non-existent past, flickering into existence for a moment before dissolving back into chaos. A Boltzmann brain would perceive a coherent world, yet it would be an illusion, a statistical anomaly in an otherwise disordered void. This concept unveils the thermodynamic memory problem. If the universe were truly random, Boltzmann brains should vastly outnumber observers like us, embedded in a low-entropy cosmos with a genuine history. Why then do we find ourselves in a universe teeming with stars, planets, and life, rather than as isolated minds, adrift in entropy's sea? The paradox strikes at the heart of existence. Our memories of a Big Bang, of evolution, of personal histories, all could be fabrications of a fleeting fluctuation. Yet the evidence from the cosmic microwave background argues otherwise. Those ancient fluctuations, preserved and amplified, suggest a real ordered genesis, not a probabilistic mirage. Scientists gazing into this abyss begin to weave a tapestry where memory and time are not separate threads, but interlaced fabrics of reality. Perhaps the universe remembers its creation because time itself is the process of that memory unfolding. In the quantum realm, where particles entangle and information spreads like ripples on a pond, time emerges from correlations, from the way systems interact and record one another. The low entropy beginning is not merely a starting point, but the origin of all records, the blank slate upon which the cosmos inscribes its evolution. Consider the inflationary epoch, that brief surge of expansion mere instants after the Big Bang. Quantum fluctuations, frozen into the fabric of space-time, became the blueprint for matter's distribution. As the universe cooled, atoms formed and light decoupled, carrying that information outward. Galaxies coalesced along those density gradients, stars ignited, planets orbited, each step a layer of memory encoded in the increasing entropy. Time's arrow, then, is the narrative arc of this unfolding, from simplicity to complexity, from potential to actuality. In the quiet expanse where the fabric of reality unravels, a deeper layer awaits. Here in the quantum realm, the universe reveals its most elusive secrets, not through the grand sweep of galaxies or the thunderous birth of stars, but in the subtle dance of particles too small to fathom. Imagine a world governed not by certainties, but by whispers of possibility, waves of probability that collapse into form only when observed, as if the cosmos itself hesitates before committing to existence. Yet amid this apparent chaos, patterns endure, etched across the vast timeline of creation, persisting from the first flicker of light to the distant echoes of cosmic evolution. These patterns are not accidents. They are the threads of a tapestry that defies erasure, hinting at a memory woven into the very essence of being. As the lens of inquiry sharpens, the quantum domain unfolds like a shadowed forest at dawn, where every leaf conceals a revelation. At this scale, particles do not behave as solid entities, bound by the predictable paths of classical motion. Instead, they exist in superpositions, embodying multiple states at once. An electron spinning both clockwise and counterclockwise, a photon traversing every conceivable route until the act of measurement forces a choice. This probabilistic governance, first illuminated in the early 20th century through the work of pioneers who peered into the atom's heart, challenges the intuitive order of the macroscopic world. Waves interfere, particles tunnel through barriers as if walls were mere illusions, and uncertainty reigns as a fundamental law, quantified in the relations that bear the name of the physicist who articulated them. But herein lies the enigma. Despite the flux of probabilities, the universe maintains coherence over eons. Stars form with reliable chemistry, light travels at an invariant speed, and the laws that birthed the Big Bang still echo in the microwave hum pervading space. How does such consistency arise from a foundation of chance? It suggests an underlying script, a hidden determinism masquerading as randomness, where the quantum fluctuations of the early cosmos seeded the structures we now behold. Galaxies, planets, life itself, all emerging from a probabilistic sea that improbably remembers its origins. The narrative descends further into the realm of entanglement, where the quantum world defies the isolation of distance. Picture two particles, born in the same fiery instant, perhaps in the core of a distant star or the collision of high-energy beams in earthly laboratories. In that moment of creation, their properties intertwine, forging a bond that transcends space. Spin one particle to the left, and its counterpart, no matter how far removed across a laboratory, a solar system, or the gulf between galaxies, instantly mirrors the change, as if communicating faster than light itself. This phenomenon, once dismissed as a paradox by skeptics who likened it to spooky action at a distance, has been confirmed through meticulous experiments, from the delicate interference of photons to the correlated behaviors of atoms cooled to near absolute zero. It implies a profound interconnectedness. The particles share not just a momentary link, but a persistent history, an informational tether that endures. Information in this context is the quantum currency, the precise states, momenta, and energies that define reality. And crucially, this entanglement reveals that such information does not dissipate with separation. It lingers immutable, a ghostly echo of unity in a divided universe. Yet, as the exploration presses onward, a shadow falls across this assurance. The colossal enigmas posed by black holes, those gravitational abysses where light itself succumbs, formed from the collapsed remnants of massive stars. These singularities warp space-time into infinite densities, their event horizons marking the boundary beyond which nothing escapes. In the 1970s, a theoretical breakthrough pierced this veil. Radiation emanates from these dark hearts, a faint glow arising from quantum effects at the horizon's edge. Pairs of virtual particles, constantly bubbling into and out of existence in the vacuum, are torn asunder, one falling inward, the other fleeing as detectable energy. This process, predicted by the physicist whose name it bears, implies that black holes evaporate over unimaginable timescales, shrinking until they vanish. But herein surges the paradox. As the black hole dissipates, what becomes of the information it has swallowed? The devoured stars, planets, and light, each carrying unique quantum signatures, seem to be erased, reduced to a featureless thermal radiation devoid of history. Quantum theory, however, stands resolute against such loss. It decrees that information is conserved, a sacred principle rooted in the unitary evolution of wave functions. To destroy it would unravel the predictability of physics itself. Thus the conflict deepens. Black holes appear to defy the indestructibility of information, challenging the very pillars of our understanding. The tension builds, a philosophical undercurrent, swelling like a tide against ancient cliffs. If information cannot truly vanish, if the quantum edict holds, then the universe must harbor mechanisms to preserve it, even in the face of gravitational oblivion. Speculation arises, grounded in the rigorous mathematics of field theories. Perhaps the information is encoded on the event horizon, a two-dimensional surface capturing the three-dimensional drama within, much like a hologram preserves depth on a flat plane. Or maybe it re-emerges in the radiation, scrambled yet intact, awaiting decryption by some cosmic observer. This paradox has spurred decades of debate, from the blackboard skirmishes of theorists to the computational simulations that model these extremes. It forces a reckoning. The universe in its quantum fidelity cannot forget. Every interaction, every collapse of probability, every particle absorbed into the void, all leave an indelible mark. The deeper mystery crystallizes. If information endures, then the cosmos is a vast archive, remembering the trajectory of every photon since the dawn of time, the spin of every electron in the primordial plasma, the gravitational waves from merging singularities. Nothing is lost. Everything is etched into the structure of reality. From this precipice, the horizon expands to encompass the holographic principle, a vision that reframes the entire universe as an intricate projection. Conceived in the late 20th century by thinkers who bridged quantum mechanics and gravity, names like those who first proposed it in the context of black hole entropy. This idea posits that the information content of a volume of space is fully described by the physics on its boundary. For a black hole, the entropy or measure of disorder scales not with its volume but with the area of its horizon, suggesting that all the complexity inside is encoded on that surface. Extrapolate this outward, and the implication stuns. The three-dimensional world we perceive, stars wheeling in the night sky, oceans surging against shores, thoughts flickering in minds, may be a holographic illusion projected from a lower dimensional reality. The universe, in this view, operates like a cosmic hologram, where every fragment of space contains the blueprint for the whole, much as a shard of a broken plate holds the faint image of the original design. This principle has found echoes in string theory, where higher dimensions curl into compact forms, and in the anti-de Sitter spaces used to model quantum gravity. It resolves paradoxes by ensuring information's preservation. What seems lost in the bulk is safeguarded on the boundary. An eternal record immune to erasure, the threads converge now, weaving a narrative that tightens with inexorable grace. Begin with the cosmic microwave background, that relic radiation from the universe's infancy, a snapshot of density fluctuations frozen in time, patterns that quantum uncertainties amplified into the galaxies we inhabit. Layer upon this quantum entanglement, binding distant realms in shared remembrance, defying the arrow of time's apparent forward march. Then confront the black holes, guardians of the information paradox, compelling theorists to envision holography as the unifying key. Each stratum of physics, from the subatomic to the cosmic, points toward the same inexorable truth. The universe is no tabula rasa, no ephemeral canvas wiped clean by entropy's advance. It is a recorder, an eternal ledger where every event imprints itself, from the Big Bang symphony to the quiet decay of protons in the far future. Speculatively, this extends to credible horizons. If holography holds, then the cosmos might be a self-referential system, where past states influence the present, not through causality alone, but through an informational fabric that loops and folds. The patterns persisting across time are not mere survivals, they are memories manifest, structures born from the quantum archive. As the realization dawns, an emotional crescendo rises, a quiet thunder resonating through the void. If memory is the essence of structure, the ordered arrangements of particles, fields, and forces that define existence, then structure itself is memory incarnate. The swirling arms of galaxies recall the inflationary epoch's ripples. The entangled pairs echo their primordial unions. Even the black holes in their holographic guise archive the fallen matter's tales. The cosmos in this light becomes memory made visible, a grand edifice built from the indestructible quanta of history. It invites reflection. In a universe that remembers everything, what does it mean for fleeting beings to exist within it? Are our thoughts, our civilizations, mere entries in this cosmic tome preserved beyond the dissolution of stars? The mystery deepens, not with clamor, but with the profound silence of eternity, where every particle whispers of what has been and what endures. This escalation propels the inquiry onward, toward realms where the boundaries of science blur with philosophy. Yet the foundation remains firm, anchored in the empirical. Experiments confirming entanglement across kilometers, telescopes mapping the microwave sky's ancient light, calculations reconciling quantum rules with gravitational might. The holographic universe, while speculative in its fullest form, draws from the entropy bounds that black holes impose, suggesting a reality more interconnected than dreamed. In this framework, information's immortality implies a cosmos alive with recollection, where the past is not prologue but presence, infused in every atom's quiver. delve deeper into the quantum probabilities that underpin it all. The wave function, that mathematical oracle describing a particle's potential states, evolves deterministically until measurement intervenes, a collapse that, in some interpretations, branches realities into a multiverse, each preserving different informational paths. In others, the collapse is illusory, with entanglement linking observer and observed in a web of correlations. Black holes amplify this. Their horizons, seething with quantum foam, may encode information in firewall-like structures or through soft hair, subtle perturbations that store data without violating no-hair theorems. Theorists have proposed resolutions where the evaporating radiation carries away the information in subtle correlations, detectable only in principle, maintaining conservation amid apparent loss. The holographic principle elevates this to universal scale. Imagine the boundary of observable space as a vast screen, projecting inward the drama of existence. Strings vibrating in higher dimensions might give rise to particles and forces, their interactions holographically dual to gravitational phenomena in the bulk. Evidence glimmers in correspondences like the AD-CFT duality, where a conformal field theory on the boundary mirrors gravity in anti-de Sitter space, a toy model hinting at deeper truths. Applied to our flat universe, it suggests that space-time emerges from quantum entanglement itself, with geometry woven from informational threads. Thus, the persistent patterns across cosmic time, from the uniform expansion to the clustering of matter, emerge as holographic encodings, memories projected from the quantum boundary. Emotionally, this evokes a sense of cosmic intimacy. The universe, in remembering, mirrors the human condition. Our minds, too, are recorders, synapses firing patterns from past experiences. Yet on the grand scale, it transcends mortality. The cosmos endures, its memory structural, eternal. If black holes are the ultimate test, their resolution affirms this. Information escapes, perhaps through wormhole bridges or unitary processes, ensuring nothing is forgotten. The narrative, tightening from radiation's whisper to holography's embrace, reveals a universe not indifferent, but inscribed with purpose, memory as the architect of reality. In this reflective vista, the mystery invites contemplation. The quantum realm, with its probabilistic veils, conceals a deterministic core of information. Entanglement binds the separated. Black holes challenge yet uphold conservation. Holography unifies the disparate. Together, they proclaim the cosmos as a living archive, where existence is the visible trace of all that has transpired. And in that visibility lies the profound. The stars above, the ground below, the thoughts within, are all echoes of an unfading memory, the universe beholding itself through time's lens. In the shadowed expanse where gravity's gentle curve meets the frantic dance of the quantum realm, humanity's greatest minds have long sought a bridge, a singular vision to reconcile the vast and the infinitesimal. Here in the quiet laboratories of thought, two profound frameworks emerge from the ether, one envisioning space-time as a tapestry of interwoven loops, the other as a symphony of vibrating strings. These are not mere abstractions, but earnest attempts to weave the laws of the cosmos into a seamless whole, where the pull of stars aligns with the whisper of particles. Consider first the notion of loop quantum gravity, a theory born from the relentless pursuit to quantize the very essence of space and time. In this paradigm, the smooth continuum of Einstein's relativity fractures into discrete quanta, tiny, indivisible loops that form the fundamental weave of reality. These loops are not static threads, but dynamic entities, spinning networks that emerge from the mathematics of general relativity fused with quantum principles. Imagine space-time not as an unbroken sheet, but as a granular mosaic, where each loop represents the smallest possible unit of volume, a Planck-scale knot in the fabric. Gravity, in this view, arises not from distant masses warping an infinite void, but from the geometry of these loops themselves, curving and twisting in response to matter's presence. It is a background-independent realm, where the stage of the universe is not presupposed, but built from the ground up, loop by loop, defying the infinities that plague other attempts at unification. Yet, as the loops entwine, they carry more than mere structure. They encode the chronicle of existence. Each configuration of these quantum loops preserves traces of interactions past, the collisions of particles, the births of stars, the inexorable march toward entropy. Space-time in this conception becomes a repository, a silent archivist etching the history of reality into its very form. The loops do not forget. They accumulate layer upon layer, like ancient sediments bearing the fossils of cosmic events. Parallel to this looped architecture rises string theory, a resonant counterpoint that reimagines the building blocks of matter not as points, but as infinitesimal strings vibrating in harmony. These strings, far tinier than any atom, oscillate in multiple dimensions, 10 in the superstring variants, or 11 in the encompassing M theory, each mode of vibration manifesting as a different particle, an electron's hum, a photon's ripple, even the graviton that conveys gravity's embrace. Here, unification unfolds through elegance. The discordant forces of nature, electromagnetism, the weak and strong nuclear binds and gravity, emerge from the same primordial strings, their differences mere variations in pitch and amplitude. Gravity, that elusive giant, is no longer an outsider but an intrinsic melody, woven into the quantum chorus. In string theory's vast symphony, space-time again serves as a canvas for information. The vibrations of strings imprint upon the higher dimensional landscape, storing the echoes of creation in brains and fluxes that span beyond our familiar 3 dimensions plus time. Like a cosmic score, these oscillations record the universe's narrative, from the Big Bang's initial crescendo to the subtle decays of distant quasars. Both theories, though divergent in method, one granular and looped, the other fluid and strung, converge on this profound insight. The fabric of space-time is not passive but informative, a medium that holds the memory of all that has transpired. From this informational essence springs a deeper contemplation, the universe as a form of cosmic consciousness, not in the ethereal sense of a divine mind, but as a self-recording system, an intricate web of data processing its own evolution. Picture the cosmos not as blind machinery, but as a vast computational entity, where every quantum event contributes to an emergent awareness woven from information's threads. Black holes, those enigmatic voids, exemplify this. As matter plunges into their horizons, the surrounding space-time cells imprint its essence, preserving data even as the whole evaporates, defying loss. The universe, in this light, monitors itself through gravitational waves that ripple outward, leaving permanent bends in space-time, or through entropy's inexorable increase, a ledger of complexity's growth. It is a consciousness born of integration, where disparate parts unify into a whole greater than their sum, echoing theories of mind that see awareness arising from connected information flows. In such a system, the stars' fusion, the planets' orbits, even the fleeting thoughts of sentient beings become entries in an eternal archive, the cosmos reflecting upon its own becoming. Yet, this self-recording tapestry extends beyond a single narrative, branching into the multiverse hypothesis, a realm where every quantum whisper births divergent realities. In the quantum haze, fluctuations, those probabilistic jitters at the heart of existence, do not merely resolve into one outcome, but spawn parallel universes, each inheriting a subtly altered imprint of the primordial memory. During cosmic inflation, the rapid expansion following the Big Bang, these fluctuations amplify, seeding not just galaxies but entire bubbles of space-time, each with its own constants and histories. Imagine a foaming sea of universes, where our own is but one droplet, carrying the echo of an initial quantum seed, perhaps a field fluctuation in a pre-inflationary void. In the many worlds interpretation, every measurement collapses not into certainty, but multiplicity, with branches unfolding like fractal veins, each preserving a variant of the cosmic story. Speculatively, this multiversal proliferation suggests the universe remembers through repetition, an eternal recurrence, where waves of probability interfere across higher dimensions. In extra dimensions, curled and hidden from our senses, these waves might overlap, reinforcing patterns like harmonics in a vast resonator. Gravitational echoes propagating through these realms could entwine memories from adjacent universes, creating interference fringes that etch deeper truths into the fabric. The cosmos, in this view, does not hoard its past in isolation, but iterates upon it, each cycle a refinement, a wave cresting in multidimensional space, ensuring no event is truly lost, but reverberates eternally. But such permanence teeters on a precipice, for lurking within quantum field theory is the specter of false vacuum decay, a subtle instability that could unravel this intricate weave. Our universe, it posits, resides not in the lowest energy state, the true vacuum, but in a metastable hollow, a false vacuum propped up by fields like the Higgs, whose values sustain the particles and forces we know. A quantum tunnel, a fluctuation piercing this barrier, could nucleate a bubble of true vacuum, expanding at light speed, rewriting physics in its wake, masses shifting, forces dissolving, the very laws of reality overwritten. Within this sphere, atoms would disintegrate, stars extinguish, the cosmic memory erased in an instant of transformation. Simulations glimpse this process, revealing the real-time dynamics of decay, a cascade from a symmetry to a new equilibrium. The universe's current state, then, is temporary, a fragile equilibrium awaiting the inevitable quantum nudge. This possibility invites profound philosophical reflection. If the universe forgets itself through such a decay, does existence reset, blank, and reborn in a stabler form? Or does every memory, every fleeting moment leave an indelible mark across space-time's deeper strata, surviving even oblivion? Perhaps the informational imprints, encoded in loops or strings, transcend the vacuum's shift, persisting as ghosts in higher dimensions or parallel branches. The cosmos, in its potential erasure, underscores the tenuousness of being, a reminder that stability is illusion, and memory a defiant act against entropy's tide. Returning to Einstein's foundational insight, relativity reframes this contemplation through the lens of time as the fourth dimension, where all moments coexist in a timeless block. In this block universe, past, present, and future are not sequential illusions but simultaneous facets of a four-dimensional manifold etched eternally. Events do not pass, they simply are, layered in space-time like strata in ancient rock, with our consciousness slicing through, perceiving flow where none exists. The Big Bang and heat death, the first cry of life and its last sigh abide side by side, an unchanging edifice. Thus the universe does not merely remember its creation, it is its creation eternally unfolding, a self-contained narrative where beginning and end entwine in perpetual now. In this view, memory is not recollection but presence, the cosmos a mirror reflecting its infinite self, undimmed by time's arrow. As these theories intermingle, loops and strings, multiverses and vacua, blocks and waves, the mystery deepens, inviting us to ponder the universe's quiet introspection. It records, it branches, it teeters, yet endures, a philosophical enigma wrapped in scientific rigor, whispering of eternities beyond our grasp. In the vast theater of the cosmos, where shadows of ancient light dance across the void, humanity has forged instruments of unparalleled vision. These are not mere machines, but extensions of our collective curiosity, probing the veiled origins of existence itself. The James Webb Space Telescope, a sentinel suspended in the cold embrace of space, gazes backward through the eons, capturing the faint glow of the universe's infancy. It peers into the epoch known as cosmic dawn, when the first galaxies emerged from the primordial haze, their nascent stars igniting like embers in a fog-shrouded forest. These early formations, shrouded in a dense veil of neutral gas, gradually burned away the obscurity, allowing light to permeate the expanding realm. Through its infrared eyes, the telescope reveals galaxies that existed mere hundreds of millions of years after the universe's explosive birth. Structures so distant that their light has traveled for over 13 billion years to reach us. In these images, one glimpses not just distant worlds, but the very scaffolding of reality taking shape, where gravity wove the first threads of cosmic architecture amid a sea of nascent matter. The telescope's observations whisper of a time when the universe transitioned from opacity to transparency, a slow unveiling that mirrors our own quest to illuminate the unknown. As astronomers sift through this data, they reconstruct the narrative of how these primordial beacons cleared the cosmic fog, their ultraviolet radiance ionizing the surrounding gas, carving pathways for light to traverse the void. It is a story of emergence, where the universe in its youth shed its infantile shroud, revealing the intricate patterns that would one day give rise to stars, planets, and the fragile spark of life. Yet, the telescope's gaze, profound as it is, captures only the luminous echoes of that distant era. To delve deeper into the very fabric of space-time itself, scientists turn to detectors that listen for the universe's subtlest tremors. On Earth, vast interferometers like the Laser Interferometer Gravitational Wave Observatory and its counterpart Virgo stand as silent guardians, their arms stretching kilometers across landscapes, attuned to the ripples that propagate through the continuum of space and time. These waves, born from cataclysmic unions of black holes or neutron stars, are distortions in the geometry of reality, propagating outward like stones cast into a still pond. First detected in 2015, they confirm predictions made a century earlier, proving that violent cosmic events send vibrations cascading across the cosmos at the speed of light. Each detection unfolds a drama of merger. Two colossal entities, locked in a gravitational embrace, spiraling inward until they collide, merging into a single, more massive form while unleashing a burst of energy that warps the surrounding space-time. These ripples carry tales from the universe's more recent history, but they also hint at deeper mysteries, echoing the dynamical interplay of matter and gravity that governed the cosmos from its earliest moments. In the symphony of these waves, one hears the universe's ongoing evolution, a chorus of collisions that reshapes the void, reminding us that space-time is not a static stage, but a living, breathing entity, responsive to the dances of its inhabitants. The signals captured thus far, however, are but whispers from relatively nearby events, mergers that occurred billions of years after the universe's inception. To reach back further, to the first fractions of a second when the cosmos was a seething plasma of energy, humanity envisions even grander instruments. In the planning stages, a space-based array known as the Laser Interferometer Space Antenna promises to extend our auditory reach into the millihertz frequencies, where gravitational waves from supermassive black hole mergers and other colossal phenomena reside. This triad of spacecraft, trailing Earth in its orbit around the Sun, will form a colossal triangle, millions of kilometers on each side, their lasers linking them in a delicate web to measure infinitesimal shifts caused by passing waves. Among its targets are the primordial vibrations, relics from the universe's inflationary epoch, when space-time expanded at rates defying comprehension, imprinting faint undulations that persist to this day. These waves, if detected, would offer a direct glimpse into the quantum fluctuations that seeded the large-scale structure we observe, bridging the gap between the subatomic and the cosmic. Complementing this aerial vigilance, ground-based endeavors like the Cosmic Microwave Background Stage 4 experiment aim to scrutinize the faint afterglow of the universe's hot beginnings. This observatory, poised at remote sites in the southern hemisphere, will map the cosmic microwave background with unprecedented precision, searching for the polarized patterns left by those ancient gravitational waves. In this relic radiation, cooled to mere degrees above absolute zero, lies a fossil record of the universe's youth, where the interplay of gravity and quantum fields etched signatures that could reveal the mechanisms of cosmic inflation. The experiment's arrays of detectors, chilled to cryogenic extremes, will discern these subtle imprints, potentially unveiling the density of light relic particles or the traces of primordial waves that rippled through the nascent cosmos. Further still, the Einstein telescope emerges as a subterranean oracle, burrowed deep beneath the Earth's surface to shield it from the cacophony of surface vibrations. This next-generation detector, with its triangular configuration of interferometers sensitive to both low and high frequencies, will probe gravitational waves from the universe's formative epochs, including those generated by the coalescence of neutron stars or the elusive signals from the Big Bang itself. Imagine it as a cosmic ear pressed to the ground of existence, listening for the faint echoes of creation's thunder. By detecting these primordial waves, it could illuminate the dark ages before the first stars ignited, revealing how gravity sculpted the void in those initial instants. Together, these future sentinels, spaceborne arrays, microwave mappers, and underground listeners form a symphony of inquiry, each instrument harmonizing with the others to compose a fuller portrait of the universe's autobiography. They seek not just data, but the underlying narrative, how the cosmos, from a singular point of infinite density, unfurled into the expansive tapestry we inhabit, with gravitational waves serving as the punctuation marks in its unfolding story. As these observatories extend our senses outward, another frontier beckons inward, into the realm of the quantum, where computers harness the peculiarities of subatomic behavior to recreate the birth of space-time itself. Quantum computers, with their qubits entangled in superposition, simulate environments that classical machines could never fathom, modeling the emergence of geometry from information. In these digital crucibles, researchers recreate the conditions of the early universe, where space-time might arise as an emergent property from quantum entanglement, much like a hologram projects 3 dimensions from a 2-dimensional surface. Speculatively, yet grounded in theoretical physics, these simulations test whether information, the fundamental currency of reality, and the curvature of space-time are interchangeable, 2 sides of the same cosmic coin. By encoding quantum fields into qubit arrays, scientists mimic the inflationary expansion, observing how virtual particles flicker in and out of existence, shaping the fabric of space. One such endeavor has even conjured a simulated wormhole, a bridge through space-time, using quantum teleportation to traverse distances instantaneously, hinting that the geometry we perceive might be woven from threads of quantum information. In this view, the universe's structure is not imposed from above, but bootstrapped from below, where bits of data entangle to form the curves and contours of gravity. These computations, though confined to laboratories, echo the philosophical musing that reality is a grand simulation, its laws emergent from deeper informational principles. As quantum processors grow in power, they promise to unravel the paradoxes at the heart of black holes, where gravity and quantum mechanics clash, suggesting that the event horizon might encode all that falls within, preserving information in a holographic veil. This pursuit leads inexorably to the enigmatic glow predicted by Stephen Hawking, radiation emanating from the boundaries of black holes, a quantum whisper from the abyss. In the quest to verify this phenomenon, scientists craft microscopic analogs in earthly laboratories, recreating the conditions of event horizons without the peril of actual singularities. Using chains of atoms or ultra-cold fluids, they simulate the curved spacetime near a black hole, where particles are torn asunder by tidal forces, one half vanishing into the void, while the other escapes as thermal radiation. These tabletop black holes, though not gravitational in nature, mimic the quantum effects that would cause real ones to evaporate over cosmic timescales, emitting a spectrum of particles that carries away mass and energy. The hunt intensifies for direct evidence, with experiments probing for this radiation in condensed matter systems, where sound waves or light analogs stand in for gravitational fields. If confirmed, it would affirm that information is not lost in the maw of a black hole, but encoded on its horizon, a firewall of quantum data that reconciles the irreconcilable. General relativity's smooth curves with quantum mechanics' jittery discreteness. Speculatively, these findings extend to the universe's dawn, suggesting that primordial black holes, formed in the chaotic aftermath of the Big Bang, might have evaporated, leaving behind traces in the cosmic microwave background or gravitational wave signals. In this light, black holes become not devourers of knowledge but guardians, their surfaces inscribed with the history of all they have consumed, a testament to the indestructibility of information in the cosmic ledger. Through these manifold tools, the telescope's unblinking eye, the interferometer's sensitive ears, the quantum simulator's intricate dances, and the laboratory horizon's subtle glows, humanity endeavors to decipher the universe's self-written tale. It is an autobiography, etched not in ink or stone, but in the warp and weft of reality. The light from ancient galaxies, the ripples in space-time, the quantum codes underlying geometry. Scientists in this grand endeavor transcend the role of passive observers. They become archaeologists of existence, delicately brushing away the dust of time to reveal the oldest imprints. Each discovery peels back another layer, exposing the profound interconnectedness of all things, from the quantum foam to the galactic clusters. In this reflective pursuit, one contemplates the mystery, a universe that began in singularity, expanding into complexity, yet perhaps looped in eternal cycles of information preservation and rebirth. The tools we wield are bridges across the abyss, connecting our finite minds to the infinite, inviting philosophical wonder at the elegance of it all. What secrets lie encoded in the structure itself, waiting for the next ripple, the next simulation to unveil? As the cosmos continues its silent expansion, these instruments stand as testaments to our enduring quest, a quiet rebellion against the entropy that seeks to obscure the origins, drawing us ever closer to the heart of the enigma. In the dim glow of observatories and the hum of quantum processors, the narrative unfolds with suspenseful grace. The James Webb Space Telescope, having captured the earliest galaxies, evokes a sense of awe at the universe's tentative first steps, like a child emerging from the womb into light. Its data, rich with spectral lines, tells of chemical abundances forged in those primeval forges, elements that would seed future worlds. Building upon this, the gravitational wave detectors add a tactile dimension, allowing us to feel the universe's convulsions, each merger a punctuation in the ongoing saga of cosmic evolution. The future missions amplify this, promising to tune into the bass notes of primordial waves, vibrations that resonate from the inflationary burst, when space-time stretched exponentially, birthing the seeds of structure from quantum uncertainty. Quantum simulations, meanwhile, offer a microscopic lens, recreating these processes in controlled realms, where entanglement weaves space-time anew, testing holography. The idea that our three-dimensional world is a projection from a lower dimensional boundary, information conserved in every twist and turn. The search for Hawking radiation in lab-crafted horizons deepens this introspection, suggesting that even in the face of apparent loss, the universe clings to its memories, encoding them on boundaries that separate the known from the unknowable. These efforts converge on a central theme: the interchangeability of information and geometry, where the curves of space-time are but manifestations of underlying data. Quantum bits entangled across vast distances. Philosophically, it invites reflection on our place within this framework. Are we mere observers, or emergent patterns in the same informational web. The tools, in their precision and ambition, embody humanity's poetic defiance, turning the abstract into the tangible, the ancient into the immediate. As waves from distant mergers wash over our detectors, or simulated horizons yield their quantum secrets, we edge closer to comprehending the universe's profound solitude and interconnectedness, a mystery that unfolds, not in haste, but in the measured rhythm of discovery. Yet the journey is fraught with suspense, each tool revealing fragments that beckon further inquiry. The Laser Interferometer space antenna, drifting in solar orbit, might one day capture the merger of supermassive black holes at galactic cores, events that echo the hierarchical assembly of the cosmos. The Cosmic Microwave Background Stage 4, scanning the sky from arid plateaus, could discern the B-mode polarization, a swirling pattern imprinted by gravitational waves traversing the plasma of the early universe, confirming inflation's wild expansion. The Einstein telescope, shielded in subterranean silence, extends this to finer details, potentially detecting waves from neutron star births or the stochastic background of countless unresolved sources, a cosmic hum underlying all. Quantum computers, evolving from nascent qubits to robust arrays, simulate not just space-time's birth, but its potential fates, exploring multiverses where information branches into infinite possibilities. In laboratories, the analogues of black holes, chains of ions or Bose-Einstein condensates, produce radiation analogues, their spectra matching Hawking's predictions, offer incredible speculation that real horizons behave similarly, resolving the information paradox by entangling outgoing particles with the hole's interior. This interplay suggests a universe where nothing is truly lost. Every event horizon, a repository of history, geometry, and information entwined in eternal dance. As archaeologists of existence, scientists dust off these memories, piecing together the puzzle of creation, from cosmic dawn's foggy emergence to the quantum roots of gravity. The narrative, mysterious and philosophical, reflects our own ephemeral nature against the cosmos's timeless expanse. A reminder that in seeking the universe's story, we author our own chapter in the grand unfolding epic. As the vast tapestry of the cosmos unfolds before us, the camera begins its slow, deliberate retreat. It drifts away from the swirling arms of a distant spiral galaxy, where stars are born in fiery nurseries of gas and dust, their light echoing the primal energies of creation. Further back now, across clusters of galaxies bound by invisible threads of gravity, these colossal structures align in patterns that span billions of light years. The view expands to encompass the cosmic web itself, an intricate lattice of filaments, voids, and nodes, where matter congregates like dewdrops on a spider's silk. These filaments glow faintly in the rendering of our instruments, not with the harsh glare of individual suns, but with the subtle luminescence of aggregated light from countless worlds. They resemble the neural pathways of an immense, infinite mind pulsing with the echoes of ancient events, connecting every point in space with the subtle hum of gravitational whispers. In this grand architecture, revealed through the patient gaze of telescopes perched on mountaintops and orbiting high above Earth's veil, we glimpse a universe that does not merely exist, but persists with a kind of deliberate continuity. Observations from space agencies have mapped this web, tracing its origins to the faint fluctuations in the afterglow of the universe's birth, a relic radiation that bathes all of space in a uniform chill, barely above absolute zero. This cosmic microwave background, captured in exquisite detail by satellites drifting silently through the void, bears the imprints of quantum ripples from the earliest moments, when the cosmos was a seething plasma smaller than an atom, yet containing all that would ever be. It is as if the universe, in its expansion from that singular point, stretched these initial perturbations into the scaffolding upon which galaxies now hang. A blueprint etched in light and shadow, yet beneath this visual splendor lies a deeper implication. one that stirs the philosophical undercurrents of our inquiry. If the universe remembers, if its very structure encodes the history of its unfolding, then we, as sentient beings woven from its stardust, become its memory made conscious. Consider the principles of information conservation, drawn from the rigorous equations of physics, where nothing is truly lost in the grand ledger of existence. In the realm of black holes, those enigmatic abysses where gravity triumphs over light, theorists have pondered the fate of information swallowed by their horizons. The resolution, emerging from decades of debate among scholars poring over mathematical models, suggests that even in these extremes, the details of what falls in are preserved, perhaps projected onto the surface like a hologram, a two-dimensional encoding of three-dimensional reality. This holographic principle, inspired by the entropy of black holes and extended to the cosmos at large, implies that the universe operates as a vast information processor, retaining every interaction, every particle collision, in its boundless archive. Expanding this notion, the cosmic web itself can be seen as a manifestation of this memory. Simulations run on supercomputers, fed with data from astronomical surveys, recreate the evolution of these filaments from the universe's infancy. Dark matter, that elusive substance inferred from the rotational speeds of galaxies and the bending of light around clusters, forms the backbone of this web. It outweighs visible matter by a factor of 5, guiding the flow of baryonic gas into the luminous strands we observe. In these models, the web emerges not by chance, but through the inexorable pull of gravity acting on initial density variations that trace back to the inflationary epoch, a brief surge of expansion faster than light itself, smoothing the universe while imprinting it with the seeds of structure. Thus, the glowing filaments are not mere accidents of aggregation. They are the universe's way of recalling its turbulent youth, a physical embodiment of memory where the past dictates the present form. As the camera continues its pullback, the scale becomes incomprehensible. The cosmic web stretching into infinity, a network that defies human intuition. Here, in this reflective expanse, every act of observation, every beam of light captured by a distant lens, every spectrum analyzed in quiet laboratories, becomes the universe watching itself. This is no mere anthropomorphism. It aligns with the foundational insights of quantum mechanics, where the act of measurement collapses possibilities into certainties. On cosmic scales, this extends to the observer's role in the universe's narrative. Telescopes peering into the depths not only reveal distant quasars, beacons powered by supermassive black holes devouring matter at the hearts of galaxies, but also probe the conditions that allowed life to emerge. The light from these ancient objects, traveling for eons across the void, carries encoded within it the chemical signatures of the first stars, those massive progenitors that forged heavier elements in their cores and scattered them in explosive deaths. Scientific discovery, then, is the universe awakening to its own story. Consider the detection of gravitational waves, ripples in space-time itself, first confirmed by observatories listening to the cosmos's subtle vibrations. These waves, born from the mergers of black holes or neutron stars billions of years ago, propagate outward, carrying tales of cataclysmic unions. When our instruments register them, we are not passive witnesses. We are participants in the universe's self-reflection, decoding messages from events that occurred when Earth was still a molten rock. This awakening unfolds layer by layer, from the mapping of exoplanets in habitable zones where liquid water might cradle life, to the study of cosmic rays, high-energy particles raining down from supernovae that hint at the violent processes sustaining galactic ecosystems. Each breakthrough, grounded in empirical data from particle accelerators and space probes, peels back the veil, revealing a cosmos that is not indifferent but intricately self-aware through the minds it has spawned. Time, in this cosmic drama, reveals itself not as a relentless river carving its path forward, but perhaps more akin to a mirror, reflecting creation through every living entity. The arrow of time, that perceived direction from past to future, arises from the increase in entropy, the universe's tendency toward disorder, as decreed by the laws of thermodynamics. Yet in the mirror of time, symmetries emerge. The equations governing fundamental particles show no inherent preference for forward over backward. It is the initial low-entropy state of the Big Bang, a highly ordered singularity, that sets the direction. Speculatively, if the universe undergoes cycles of expansion and contraction, as some cosmological models propose based on extensions of general relativity, then time might loop in reflective patterns, each era mirroring the last in inverted form. In living things, this reflection manifests vividly. Biological evolution, driven by natural selection on genetic information, mirrors the cosmic evolution of structures, where complexity arises from simple rules repeated over vast scales. Through the lens of astrobiology, informed by missions to icy moons and rocky worlds in our solar system, we see life's tenacity as a reflection of the universe's creative impulse. Microbes surviving in extreme environments on Earth echo the potential for life in subsurface oceans, beneath frozen crusts elsewhere. The building blocks of life, amino acids and organic compounds, detected in meteorites and interstellar clouds, suggest that the chemistry of existence is woven into the fabric of space itself. Time's mirror thus projects the Big Bang's energy forward, through the formation of stars, the synthesis of elements, and the emergence of consciousness, where beings like us ponder the reflection. This is not idle speculation. It draws from the credible extrapolations of researchers modeling the universe's fate, whether in a heat death of eternal expansion or a big crunch of reversal, each scenario reflecting the initial conditions in profound ways. Now, as the emotional crescendo builds, consider humanity's gaze upward. When eyes turn to the night sky, unpolluted by city lights, it is not merely stars that captivate. It is history unfolding in real time. The light from Andromeda, our nearest galactic neighbor, departed 2.5 million years ago when early hominids first wielded tools on African savannas. Closer still, the constellations tell tales of myth, but beneath them lie the scientific truths of stellar life cycles, red giants swelling to engulf inner planets, white dwarfs cooling into eternal embers. In this act of looking, humanity beholds order emerging from chaos. The precise constants of nature, fine-tuned to allow atoms to bond, stars to ignite, and life to flourish. Memory is interlaced here, in the cosmic microwave background's whispers and the fossil records of light from distant supernovae, events that seeded the heavy elements in our blood. This weaving of history, order, and memory in light evokes a profound resonance. The spectra of distant galaxies, redshifted by the universe's expansion, measure not just distance but the passage of epochs, confirming models of an accelerating cosmos driven by dark energy, a mysterious force comprising most of the universe's content. Philosophical threads intertwine. If memory is the thread binding past to present, then the universe's retention of its genesis ensures a form of immortality. Black holes, once thought to erase information, now theorized to preserve it through subtle radiation, suggest that even in dissolution, existence persists. The cosmic web, with its filaments echoing neural connections, hints at a universe akin to a thinking entity, where galaxies are synapses firing across the void. In remembering its creation, from the inflationary burst that smoothed horizons to the first light piercing the plasma fog, the universe defies oblivion. Entropy may rise, scattering energy into uniformity, but information endures, encoded in the curvature of space, the spin of particles, the orbits of worlds. Existence in this view cannot truly die. It transforms, reflects, and re-emerges in new forms. The philosophical close settles like a gentle dusk. Memory is immortality, a safeguard against the void. And so, with gravitas and wonder echoing through the infinite expanse, the truth reveals itself. The universe began in darkness, but it never forgot the light. To deepen this reflection, let us linger on the cosmic web's intricacies. Astronomical surveys compiling data from thousands of galaxies reveal that these filaments are not static. They evolve, drawing matter inward like rivers feeding oceans. The voids between them, vast emptiness comprising over half the universe's volume, are not barren but laced with diffuse gas, detectable through absorption lines in quasar light. This gas, heated by the web's formation, cycles through galaxies, fueling starbirth in a cosmic ecology. Speculatively, if the universe harbors a form of memory, these cycles could be seen as recursive thoughts, each iteration building on the last, much like neural networks in biological brains learning from experience. Turning to the holographic principle, its roots trace to calculations of black hole entropy, proportional to surface area rather than volume, challenging our three-dimensional intuitions. Extended cosmologically, it posits the universe as a projection from its boundary, perhaps the infinite horizon at the edge of observable space. This credible speculation, supported by string theory frameworks, implies that all events are inscribed on this boundary, an eternal record where time's flow is illusory, a reflection in the mirror of dimensions. In the realm of observation, the universe's self-watching gains poignancy through quantum entanglement, where particles linked across distances influence one another instantaneously, defying locality. On cosmic scales, entanglement might underpin the uniformity of the microwave background, connecting regions beyond light's reach during inflation. Discoveries like these, from collider experiments smashing particles to mimic early conditions, awaken the universe to its quantum heritage, a story of interconnectedness where separation is but an illusion. Time's mirror reflects in the symmetry of physical laws, broken only by entropy's arrow. Yet in weak interactions, subtle asymmetries favor matter over antimatter, explaining why the universe contains substance rather than annihilating into pure energy. This imbalance, measured in particle decays, mirrors the conditions allowing for life's emergence, a philosophical loop where time's direction enables reflection itself. Humanity's upward gaze encompasses the history of astronomy, from ancient stone circles aligning with solstices to modern arrays detecting fast radio bursts, mysterious signals from neutron star mergers or magnetars. These bursts, lasting milliseconds, carry energy equivalent to the sun's output over days, weaving tales of extreme physics into our night sky, expanding the emotional crescendo. The light we see is memory incarnate, photons from the Orion Nebula, birthplace of stars, departed when pyramids rose in Egypt. Order manifests in the hierarchical structure of the universe, from quarks to quasars, governed by forces in delicate balance. Dark energy's repulsion, inferred from supernova distances accelerating apart, ensures the web's eternal expansion, a canvas for memory's preservation. Philosophically, if memory confers immortality, the universe's self-remembrance through laws and structures defies finitude. In potential multiverses bubbled from eternal inflation, each variant remembers its unique genesis, an infinite tapestry of possibilities. Thus the cosmos endures, its light eternal. Delving further into the neural analogy, the cosmic web's filaments host galaxy clusters as nodes, where supermassive black holes orchestrate matter flows. Feedback from these holes, expelling jets of plasma, regulates star formation, akin to synaptic pruning in brains. Data from X-ray observatories show these jets carving bubbles in hot gas, sculpting the web over billions of years, a slow, deliberate memory formation. The information paradox resolution, via Hawking radiation's subtle correlations, suggests black holes evaporate while preserving data. a process taking longer than the universe's age for large ones. This ensures cosmic memory's longevity, speculatively linking to wormholes or quantum gravity theories. Observation's role extends to the anthropic principle, where the universe's constants seem tuned for observers, a reflective self-selection. Discoveries of fine structure constants uniformity across space support this, implying a cosmos designed for its own contemplation. Time as mirror reflects in reversible processes like light propagation, where paths forward and backward are indistinguishable. The arrow emerges from initial conditions, perhaps set by quantum fluctuations during inflation, mirroring creation in every moment. Humanity sees in stars the forge of elements, carbon in our cells from triple alpha processes in stellar cores, oxygen from massive star explosions. History weaves through cosmic rays altering DNA, order in Kepler's laws governing orbits, memory in geological strata echoing stellar births. In closing, the universe's remembrance immortalizes existence, from Big Bang to heat death, information persisting in quantum fields. Final line. As the vista of the cosmos widens in our mind's eye, the camera embarks on a leisurely withdrawal, gliding backward from the luminous embrace of a single galaxy, a pinwheel of stars, gas and dust, where gravity orchestrates a silent ballet of formation and destruction. The spiral arms recede, revealing the galaxy as but one jewel in a cluster, bound together by the unseen hand of dark matter, that phantom substance inferred from the subtle distortions it imposes on visible light. Further still, the view encompasses superclusters, vast assemblies where gravity's pull has drawn matter into alignment over eons, creating bridges across the abyss. And now the cosmic web emerges in full majesty, a lattice of filaments, stretching like glowing veins through the void, interconnecting nodes of galactic light with the faint radiance of ionized gas. These filaments, mapped through the tireless vigilance of astronomical surveys, pulse with the aggregated glow of trillions of stars, their structures evoking the intricate pathways of neurons in a boundless brain, an infinite mind, where each connection hums with the resonance of ancient origins. This web is no random scatter. It is the universe's grand architecture, forged in the crucible of its earliest moments. Data from space telescopes, capturing the faint microwave afterglow that permeates all of space, reveal the seeds of this structure. Tiny variations in temperature, mere millionths of a degree, that trace back to the quantum fluctuations of the universe's infancy. When the cosmos was a mere fraction of a second old, an explosive expansion, driven by forces described in models of cosmic inflation, amplified these ripples, stretching them across the canvas of space-time. As the universe cooled, gravity took hold, pulling denser regions into the filaments we see today, while leaving vast voids as empty testaments to the initial uniformity. The light we detect from distant quasars, those brilliant beacons at the hearts of young galaxies, passes through these filaments, absorbing specific wavelengths that betray the presence of hydrogen and helium, the primordial elements from which all else arose. In this way, the cosmic web stands as a living fossil, a physical inscription of the universe's birth narrative, where the past is not erased but etched into the very fabric of reality. Beneath this visual splendor lies a profound implication, one that invites contemplation on the nature of existence itself. If the universe remembers, if its laws and structures encode the history of every particle, every wave, every gravitational tug, then we, as beings born from its elemental forge, embody that memory in conscious form. This is not mere poetry. It draws from the bedrock of physical principles, where information is conserved amid the flux of change. In the shadowed realms of black holes, where space curves inward to infinity, scientists have grappled with the fate of what falls beyond the event horizon. Calculations rooted in quantum field theory suggest that even as matter is compressed to singularity, its informational essence endures, perhaps radiated back into the cosmos, through subtle emissions over unimaginable timescales. This resolution to the information paradox, debated in scholarly papers and refined through mathematical rigor, posits the universe as an indelible archive where no detail is lost to oblivion. The holographic idea extends this further. The three-dimensional volume we perceive may be a projection from a two-dimensional boundary, much like a hologram encodes depth on a flat surface. In such a framework, the cosmic web's filaments could be seen as projections of deeper informational patterns, threads in a tapestry that recalls every twist of fate since the dawn. Speculatively, yet credibly grounded in these theories, the universe's memory manifests in the persistence of cosmic structures. Computer simulations, fed with observational data from galaxy catalogs, recreate the web's evolution, showing how dark matter detected indirectly through its gravitational lens on light forms halos that cradle visible matter. These halos, invisible yet dominant, guide the collapse of gas clouds into stars, a process observed in nebulae where infrared telescopes pierce the dust to witness birth. The web's nodes, where filaments intersect, host the most massive galaxy clusters, environments where hot gas emits X-rays, revealing temperatures soaring to millions of degrees. Here the universe recalls its violent youth. Collisions between clusters send shockwaves rippling through space, accelerating particles to near-light speeds and generating magnetic fields that thread the filaments like synaptic signals. If this web mirrors a neural network, then its thoughts are the slow migrations of galaxies along these paths, drawn inexorably toward greater density, a cosmic contemplation unfolding over billions of years. As the camera's retreat accelerates, the scale defies comprehension. The web sprawling into the horizon of the observable universe, a bubble of light extending some 93 billion light-years across, limited not by distance alone, but by the finite speed of light since expansion began. In this expansive silence, every act of observation becomes the universe beholding its own reflection, a self-awareness woven into the act of discovery. This echoes the quantum realm, where the measurement of a particle's state influences its reality, collapsing waves of probability into definite form. On grander scales, our telescopes serve as the universe's eyes. Instruments orbiting Earth capture the spectra of distant supernovae, explosions that mark the death of massive stars and scatter the heavy elements, iron, gold, silicon, essential for planets and life. These spectra, redshifted by the universe's stretch, confirm not only the expansion but its acceleration, driven by a pervasive energy that fills empty space. Each detection, from the faint gravitational lensing of background galaxies to the polarization patterns in the microwave background, unveils layers of the cosmic story. As if the universe, through our inquiries, stirs from slumber to narrate its saga, scientific pursuit thus awakens this narrative. Probes venturing to the outer solar system return data on comets, icy relics from the era when planets coalesced, carrying organic molecules that hint at life's universal potential. On Earth, accelerators recreate the high-energy conditions of the early universe, producing particles that fleetingly mimic the plasma soup from which quarks and gluons condensed into protons and neutrons. These experiments, corroborated by observations of neutron star mergers, events that forge rare elements in their fiery embrace, reveal a cosmos interconnected, where the death of one star seeds the birth of another. Speculatively, if consciousness arises from complexity, as seen in biological evolution from single cells to neural networks, then the universe's vast web might foster emergent awareness on scales we can scarcely imagine. With each discovery a spark in that awakening, time in this reflective cosmos appears less as an unyielding current and more as a polished mirror, casting creation's image forward through every entity it touches. The laws of physics exhibit symmetries. Equations describing electromagnetic forces or strong nuclear interactions remain invariant under time reversal, suggesting that processes could unfold backward as easily as forward. The direction we perceive, the arrow pointing from order to disorder, stems from the universe's initial state, a low-entropy configuration where all matter and energy were compressed into exquisite simplicity. As expansion proceeded, entropy increased, scattering that order into the diversity of stars, planets, and life. Yet in the mirror of time, echoes persist. The matter-antimatter asymmetry, a slight preference for matter observed in particle decays, explains why the universe did not annihilate itself into pure radiation. This imbalance, quantified through experiments at high-energy facilities, reflects the conditions allowing for structure to endure. Credible models speculate on time's deeper nature. In cyclic cosmologies, the universe might contract and rebound in endless loops, each Big Bang mirroring the crunch of the previous. Living beings embody this reflection. Metabolic cycles in cells mirror stellar nucleosynthesis, where fusion builds complexity from simplicity. The fossil record on Earth, layered with evidence of mass extinctions and adaptive radiations, parallels cosmic epochs from the Rhionization era, when first stars lit the darkness, to the present star-forming peak. Time's mirror thus propagates creation, ensuring that the primal light's energy infuses every atom, every thought. The emotional swell rises as we contemplate humanity's place in this vista. When gazes lift to the heavens, it is not isolated points of light that greet us, but a chronicle etched in photons. The glow from the Pleiades departed when ancient civilizations etched their first scripts, carrying tales of stellar nurseries where new worlds form. This upward look reveals history's weave, the Big Bang's afterglow uniform across the sky, testifying to a shared origin. The orderly spirals of galaxies, governed by conservation laws that balance rotation and gravity. The memory preserved in meteorites, bearing isotopic signatures from ancient supernovae. Light itself is the medium, a messenger traversing the void, its paths bent by massive clusters to create multiple images of distant objects, a gravitational echo of the past. Order emerges in the fine balance of forces, gravity's pull countered by expansion's push, allowing clusters to form without collapse. Memory resides in the cosmic inventory, the abundance of light elements predicted by nucleosynthesis models and matched by observations, a ledger of the first minutes. Woven together, these elements stir a sense of kinship with the infinite, where looking up is an act of remembrance. In philosophical repose, memory emerges as the essence of immortality. The universe, by retaining its genesis in every law, every field, every curvature, defies the finality of decay. Entropy may diffuse energy into equilibrium, but information, the arrangement of quanta, persists, perhaps in the quantum vacuum's fluctuations or the event horizon's encodings. Existence, thus remembered, transcends endings and eternal reflection in the mirror of being. With the weight of wonder settling upon the soul, the revelation dawns. The universe began in darkness. But it never forgot the light.